Okay, so in the previous class, we started discussing about this function, the DES function, which is called the heart of DES. Okay, and in this we saw that how these 32 bits of the plain text, we divided those 64 bits of the plain text into two parts, 32 bits, each of 32 bits, and we were dealing with this right part of the message, which is of 32 bit. Okay, and we saw that we expanded this 32 bit to make it a 48-bit data. Okay, so I told you about this expansion thing using that table. Okay, and then these 48 bits are XORed with this key of 48 bit, and as an output we get these 48 bits, right? So up to here we discussed in previous class. So today we are supposed to discuss this working of S boxes, which we use in this function of DES. So in total we use 8 S boxes, and these S boxes will convert this 48 bits into 32 bits. Okay, because after all the left part and the right part of the message, they in total they are of 64 bits. Okay, so for its calculation with this key, we have made we made this 32 bit as 48 bits. But now after after we get the output from this function, we need to XOR this output of the function with the left part of the plain text, right? So we need to convert these 48 bits to 32 bits. So for that purpose we require these S boxes. Now we'll see that how these S boxes will work, right? So that is the expansion part of this initial component. Okay, and that this was the expansion p box table. Now these are the S boxes. So as I already told you that these S boxes, they will convert the 48-bit data into 32-bit data, right? So what we do is the input to these S boxes will be of 68 6 bits. Now we will since we are having 8 S boxes, so we will make 6 blocks out of it. Okay, sorry, 8 blocks out of it, each having 6 bits, right? So we have made these 8 blocks out of this 48-bit input. Now each block which is of 6 bit, we have to change this block to 4 bits, right? So that in total the output which we get after passing through this S box, in total that output should be of 32 bit, right? So how this compression of data is done using S boxes, that we will discuss, right? So for this purpose we have a dedicated table for each and every S box. Okay, so in total we'll be having 8 tables, one for each and every S box, and we will make use of that table to convert this 6-bit block into 4-bit block, right? So now we'll see that how do we use that table for this conversion. So that is how we make use of this S box rule to convert these 6 bits into 4 bits. So what we do is we will consider this first bit and last bit of the given block to find out the value of the row or the index of the row, and the middle 4 bits will be used to find out the number of the column. Okay, so using these 6 bits, what we'll have with us, we'll have a value for row and a value for column, right? So we will see that that particular row and that particular column where do they intersect. तो जहाँ पे भी वो intersect होंगे उस value के corresponding will be finding out the value. Okay, and that value we will be converting it into 4 bits, and then we'll find our 4 bits. So how do we do this? This might sound confusing right now, but I'll tell you with example that how does it work. Right, so here these 6 bits will be given to you. So we'll be using first and last bit for row, and these middle 4 bits for column. So how do we do this? Say this is the table for S box 1. So just like this table, we have 8 tables with us, one for each S box. Right, so this is the table for S box, S box 1. So in this, we will see, now see here in this table, the entries are in decimal, but actually they are in binary. So they are represented in decimal just to save the space over here. Right, so I'll tell you the example now, that how do we use this table to convert these 6 bits into 4 bits. Now say for example, the input to this S box 1 is this one, right? Now what will be our output? So here we can see that this is 6-bit data, okay? And out of these 6 bits, this first bit and the last bit will tell you about the row information. And these 4 bits will tell you about the information of column. How do they do that? Now we will write the first and sixth bits together. So we get 1 1 for this example. This first bit is 1, last bit is 1. So we get 1 1 as a result. So 1 1, this is in binary, right? Because these 6 bits are in binary. So we will convert this binary into decimal. So this 1 1 in decimal is 3. Okay, so now the information about row, or the row number which we have, is 3. Okay, right. Now for the column, what we do, we will consider these 4 bits which are in middle, right? So these remaining bits which are 0001, they are in binary and they represent 1 in decimal. Okay, so this will be the information for column. So now we have the numbers with us for the row and column. So we have to check the entry for third row and first column, right? So we look for the value in row 3 and column 1 in the table which is which belongs to that particular S box for which we are right now dealing. So the result is 12 in decimal. So here we can see we have this third row, right, and one column. So the entry corresponding to these two values is 12, which is in decimal. So we have to convert this decimal into binary, right? So when we convert 12 into binary, then the result we get is this one. So this value, as you can see, this is 4-bit. Okay, so for this particular input, which is 10011, we have this output which is of 4-bit. So here this input is 6-bit and output we are getting is of 4 bits. So this is how these S boxes work, right? So here you can see in this table that because we are considering 4 bits for finding out the column number and 2 bits for finding out the row number. So in total we'll be having 2 raised to 4 columns. Okay, 2 raised to 4 means 16. So 0 to 15 we are having column numbers, and 2 bits we are considering for finding out the row number. So 2 raised to 2, this will be the maximum number of rows we can have in this table, right? So these 4 are the rows which we have. So these, these tables are different for each and every S box. We have one more example, which is, for S box 8, right? So this is the input, which is, all 0. So we are to check for this output of this particular input. So this is of 6 bit, okay, and the output must be of 4 bits. So what we'll do is we'll again check for this first and last bit, which will tell you about the row number, and these middle 4 bits will tell you about the column number, right? And we have to check for the entry under 0th row and 0th column in table 8. Okay, so this will be for this specified S box table, right? So when we see this entry for 0th row and 0th column, the entry in S box 8 table is 13. Okay, so 13, which is in decimal. So when we convert this 13 into binary, we get this value. Okay, so this will be the output for this particular input, right? So this is how these S boxes work. Okay, so after these after this data, this 48-bit data, it passes through all these S boxes and it gets converted into 32-bit. It goes to this straight P box, okay, which is the last component of this function, des function. Okay, so here we have expanded the right part of the message, then we have XORed it with the key, then we have compressed the size of and these 48 bits to 32 bits. Now we have to input these 32 bits into this straight P box, which will again be a permutation table. Okay, so the bits will be permuted, and as a result we will get the output from this des function. So the table which we use for this straight P box will again be using the same rule. The value of the value at any index will tell you about the input, and that index will tell you about the output. So this 7, for 7 input, the output will be 2. Okay, so this 7 bit will be changed to second bit. This first bit will be changed to, yes, this is table which is having 8 columns in it. So this first bit will be changed to the 9th bit, right? So this is how the straight permutation table work, which is the last component of this des function, right? So now we are done with this des function. Now we'll see that how these keys are generated, okay, because we have not talked about it, because this key is actually we use this initially this size of this key is 56 bit, okay, and then we convert it into 48 bits and then we use it, right? So how do we change its size and all that we'll talk now. Okay, so this round key generator, it creates 16 48-bit keys out of a 56-bit cipher key, right? So it says that actually the key which we use initially is of 64 bits, right? But we drop 8 bits out of it, and we call those bits which we drop as parity bits. Okay, so actually we make use of these 56 bits only, and out of these 56 we use 48 bits. So we have to change these 56 bits of the key to 48 bits, right? So I'll show you its process, the whole process of key generation. How does it work? So here you can see the initially the initial value of or the initial number of bits in the key with parity is 64, right? Then we use this parity drop, which drops 8 bits out of this key, and as a result we get the cipher key of 56 bits, right? Then after that, this 56-bit key is divided into two parts, and each part is of 28 bits, right? So this whole thing is this is a key generator. ओके जैसे हमने फंक्शन को डिस्कस किया है, पूरा उसका हर एक कंपोनेंट डिस्कस किया है, वैसे ही हम लोग अभी की जनरेशन प्रोसेस कैसे होता है डीईएस में, दैट इज व्हाट वी आर डिस्कसिंग. Okay, so we make two parts out of it, the whole key, the whole cipher key. Then we perform the shift left operation to each part, right? And then we compress this key. Why do we compress it now? Because this cipher, the complete size of this key is 56 bit, okay, but the data which we are having is 48 bits, right? So that 48 bit data is to be supposed to be XORed with 48 bit of key. So we need to compress here this 56 bits into 48 bits, right? So for that purpose we use this compression p box. Okay, so for the first round what we do, after shifting left these bits, okay, which are acting as input, after shifting them left we will use this compression p box, and then the output of this compression p box will be the first key, okay, which will be used for round 1. Now for the second round we will again shift left the bits of the key, then we will use these shifted bits of the key and will again compress them, and then as a result we get the key for the second round. And this process goes on for 16 rounds, because we have 16 rounds in DES, so 16 different sub keys will be generated. But for each and every key, for generation of each and every round key, the process will be same. First we shift left the bits of the key, then we compress it using compression p box. Now for shifting the bits of the key we have this rule, okay, for round 1, 2, 9 and 16 we shift only 1 bit, and for other rounds we shift 2 bits. Okay, so that is the thing we have to consider while generating the keys, right? So this is the whole process of key generation. This is how we generate keys for each and every round. Now these are just explanation which I have already told you. This parity drop, it drops 8 bits, and which 8 bits are dropped? This bit number 8, bit number 16, 24, 32, 48, 56 and 64. So these 8 bits are dropped to make a 56 bit key out of 64 bit key, okay, and then it permutes the rest of the bits according to the parity drop table. This table we have with us, which is this one. So this is the parity bit drop table which we have got after dropping these 8 bits from the 64-bit key. So this particular table is having 56 entries, okay, and there are no there are these values or these bits are not available in this table. Bit number 8, 16 and so on up to 64. So every 8th bit is being dropped to convert this 64-bit key into 56-bit key. Okay, so this parity bit drop table, it is predetermined. We have this table with us and we can use this table as it is, right? Next is the shift left. So after this parity drop, this 56-bit key is divided into two 28-bit parts, which I already told you, and each part is shifted left 1 or 2 bits depending on which round we are dealing with. So 1, 2, 9 and 16 उनके लिए one shift होगा, and for rest of the rounds there will be 2 shifts. Right, so the two parts are then combined to form a 56-bit part. We have this table also for a shifting thing. Okay, this is telling you that this is 1, 2, 9 and 16. These rounds are having only this 1-bit shift and rest of the rounds are having 2-bit shift, right? Next we have this compression P box. Now this 56-bit which we have got after shifting operation, this will be fed into this compression P box, which will convert this 56-bit key into 48-bit key for that particular round, right? So if we are in round 1, then in that case key 1 will be generated. If we are in round 2, then key 2 will be generated. Fine. So this is how this whole thing works. Now this is the key compression table जो जिसका last component है this one. इस compression के लिए we make use of this key. So we can see over here that initially we had 64 bits. So 8 by 8 table we had. After parity drop we had only 56 bits, right? So this is 8 by 7 table. Okay, the size of this table is 8 by 7, and after compressing it we have this table of size 8 by 6, right? So 48 bits we have now, so we make use of this table for compressing the key, right? Okay, so that's all about this DES structure. Okay, we are done with the DES structure now, in which we have discussed about each and every component of the structure in detail. Now this is an example which it simply shows you that which steps we follow and how these rounds are followed. So only results are given over here. Okay, so this is plain text. Okay, and this is key we have. So first what do? We initially permute. Okay, the initial permutation, which was the first step. So after initial permutation we get this value for the plain text. Then we divide it into two parts, which is the left part and right part. Then we perform the DES function, okay, using these left and right parts. And in those DES function we have several rounds in which we will generate the keys for each and every round. So here you can see the value of this left part of plain text and right part of plain text is being changed in each and every round along with these keys. So keys are also changed, right? So in total we'll be having these 16 rounds. Okay, and after all the operations, the final permutation and all other operations, we get this ciphertext, right? This is after final permutation, which is the last step of the DES structure, right? So this is the encryption part. Now at decrypting end we will take this ciphertext. The whole process will be performed in reverse. पहले जैसे initial permutation होगा, फिर उसके बाद will be performing this DES function in which हम लोग पहले swap करेंगे, फिर mix करेंगे values को. Will be having 16 rounds in at the decrypting end as well, wherein for each and every round a different key will be generated, right? So this is the plain text which we get for this ciphertext. So we can see that this plain text and the plain text which we had over here, they are similar, right? So this is, all about this DES structure. So in the coming class, we'll be discussing some more aspects of DES, wherein we'll be discussing its strengths, its weaknesses, and all other things.